Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 3 of the video on partial fractions, and in this video I'll be taking you through an example with a repeated linear term on the denominator. Okay, so here we have, write x squared plus 8x plus 9 all over x plus 1 times by x plus 2 squared in partial fractions. Now, what I mean about repeated linear term is here. That squared means it's repeated. We have x plus 2 times by x plus 2. So this is referred to as a repeated linear term. And you have to do that, you have to deal with that in a particular way, a specific way. So let's start off by writing x squared plus 8x plus 9 over x plus 1 x plus 2 squared is equivalent to. Now, you are going to need 3 terms because there are 3 terms on the denominator. So it's going to be a over x plus 1 plus b over x plus 2. Sometimes people think it would be c over x plus 2 as well, but it's not. If you have a repeated term on the denominator like this, we have this term twice, you have to have it once, and in the next partial fraction you have to have it twice. And what I'll do briefly at the end of the video, I'll explain why, but for now I'll just go through how to solve the problem. So again, what we're doing is we are going to cross multiply on the right hand side to obtain a common denominator, and we just need to think very carefully about which terms we need to multiply by, because in this example it's ever so slightly different. So a over x plus 1, I'm trying to obtain the same denominator for this fraction as I have on the left hand side, which would mean that I would need to multiply a by x plus 2 all squared, because I already have the x plus 1. Now with b, let's just think carefully about this. I already have x plus 2, so I would need x plus 1. But because that x plus 2 is squared, it's repeated, to make the denominator the same, I would need to multiply by another x plus 2. So that's what I'd have on the b term. And then the c term. Now, I have x plus 2 squared, and I'm trying to obtain this denominator here. So I already have x plus 2 squared, which means I only need to multiply the c fraction, numerator and denominator, by x plus 1. So people sometimes make mistakes here. They end up with too many terms going on here, getting it into a bit of a pickle, and it's always this last one where you have x plus 2 squared on the denominator. You only need one term additionally on the numerator and denominator to make it an equivalent fraction. So as I did with the last example, that whole thing is going to be over the same denominator, x plus 1, x plus 2 all squared, because we're adding those 3 fractions with their common denominator. And that is equivalent to my original expression that I was given, x squared plus 8x plus 9 over x plus 1 times by x plus 2 all squared. Now again, I have the same denominator on both sides of my identity, therefore the numerators must be the same as each other. So I can deal just with the numerators now and write that x squared plus 8x plus 9 is equal to a x plus 2 squared plus b x plus 1 x plus 2 plus c x plus 1. And if you're thinking, oh yeah, I've seen this all before, skip, stop, don't, because there's something a little bit quirky with this one. Watch it through to the end. Okay, remember the strategy, we're trying to make these brackets go to 0. So the first x value that I'm going to choose is x equals negative 2. So substitute that in on the left hand side, negative 2 all squared plus 8 lots of negative 2 plus 9. Now that is going to equal, if I sub negative 2 in here, I'm going to get 0 squared. If I sub negative 2 in here, I'm going to get negative 1 and then 0. And if I sub negative 2 in here, I'm going to get negative 1. So again, 2 of the terms going to 0 leaves me with just 1 that I'm going to find. Careful working this out. Negative 2 squared is positive 4. Take away 16, negative 12. Add 9 is negative 3. And that equals negative c, which means that c is 3. The value of c is positive 3. Okay, continuing on the journey, trying to make the next bracket equal 0, I need to make x equal negative 1. So substitute it in on the left-hand side, negative 1 all squared plus 8 lots of negative 1 plus 9 equals a. Now, if I put negative 1 into here, I'm going to have 1 squared plus b. If I put negative 1 in here, I'm going to get 0. And if I put negative 1 in here, I'm going to get positive 1. And then plus c. If I put negative 1 into here, I'm going to get 0. So again, 2 terms going to 0, leaving me with just the 1 that I'm going to solve. Negative 1 squared is 1. Take 8 is negative 7. Add 9 is positive 2 equals a times 1. So the value of a is positive 2. Okay, so I've used negative 2, I've used negative 1. What do I do now? It appears as though I've run out of x values, but we don't have to choose x values that turn these brackets into 0. We can choose any x values we wish, as long as we put them into both sides of the expression. In this case, I'm going to need to do that. So let's choose a really nice number, easy number. X is 0. So let's use x equals 0. Subbing it in on the left-hand side, I'd have 0 squared plus 8 lots of 0 plus 9 is equal to a times by, if x is 0, I'd have 2 squared plus b. If x was 0, I'd have 1, 2, so times 1 times 2. And then with c, if x was 0, I would have 1. So what that would give me, 0 plus 9, so it's 9, equals 2 squared is 4, so 4a. 1 times 2, so plus 2b, plus c. And you might think, well, how has that helped? Well, that's helped because we already know the value of a, and we already know the value of c from our previous working. So what I can now do is I can say that it's 4 lots of 2 plus 2b, b is the one that I still don't know, plus c, which is 3. So 9 equals 8 plus 2b plus 3. So subtract that, I have 2b equals negative 2, and that leads me to b equals negative 1. And now, as I keep saying, when you write your final expression, just make sure that you get the correct values on the correct fractions. That's the only thing that can go wrong at this stage. So let's take our time and get that right. So we have shown that x squared plus 8x plus 9 over x plus 1 times by x plus 2 squared is equivalent to a over x plus 1. So a is 2. So 2 over x plus 1. Plus b over x plus 2. So b is negative 1. So I'm going to put a minus here. 1 over x plus 2. Plus c over x plus 2 squared. I know that c is 3. So plus 3 over x plus 2 all squared. Let's make that look a little bit more like a 3. There we go. And that is that expression separated into 3 partial fractions. But the key point from here was that if you have a repeated term on the denominator, you need to have it once and then you need to have it twice. Sometimes the questions are set out like this, it reminds you, you just see it, happy days, just go for it. But if it's phrased how I phrase the question, which is just to write this in partial fractions, people often will miss that you need it once, you need it twice. So that's the key learning point from this one. If you were wondering why did we have to have it once and then have it twice, very, very brief explanation. If you didn't have that squared there, you have b over x plus 2 plus c over x plus 2. We have a common denominator, so it would actually add to be one single fraction. So you wouldn't end up with two terms on the denominator, three terms, sorry, on the denominator. You'd only end up with two because these two are the same. And that's why we need the second one to be squared, because then we have three different denominators within our partial fractions. Thanks for your company.